We're going to complete this page to develop the double angle identities. With cosine x plus x, we can think of that as cosine 2x. So with x plus x, that goes for the alpha and the beta. So we have cosine x plus is the top symbol. So we're going to take the top symbol here minus sine x. So that gives me cosine squared x minus sine squared x. This is going to equal cosine 2x. That's one of the double angle identities because 2 is double. Now for sine, we're going to do the same thing. A and B are both x and x. So we have sine x, cosine x, plus in between the two angles is the top symbol. So I take the top symbol here, another plus, and then cosine x, sine x. When you multiply, the order does not matter. So I can think of sine x, cosine x plus, and just so that this matches, that's also sine x, cosine x. We have two sine x, cosine x terms. One here plus one more here. So this is the sine double angle identity. Now for tangent, that's going to give us tangent x plus tangent x divided by, plus on the top. So we take the top, and the numerator is plus, the denominator is minus. So tangent plus tangent makes two tangents. 1 minus tangent times tangent is tangent squared. Just like our other identities, so this is tangent 2x. I can also think of tangent 2x as sine divided by cosine. So that would be sine of 2x divided by cosine of 2x. So if you look at your formula sheet, or turn the next page in your packet, on your formula sheet in my purple box here, these are the only double angle identities you're given. No tangent double identity. So for any tangent, I would usually do sine divided by cosine. I do not want to memorize this top one. So we can use these double identities just like we did all the others. If we are given sine of x is negative 4 over 5, this is quadrant 4. Y and R. We can use Pythagorean theorem to get the missing leg. And then expanding out sine 2x, that's 2 sine x cosine x. So then from our picture here, sine is negative 4 divided by 5. Cosine is 3 divided by 5. 2 needs a denominator. Multiply numerators, so that's negative 8 times 3. And 5 times 5 times 1. That is our sine 2x answer for this specific problem. For cosine 2x, we have 3 different choices. We can either use the one we just developed on the prior page, cosine squared minus sine squared, or the formula sheet gives you other forms where they've replaced sine squared with the Pythagorean identity from our last unit, or they replace cosine squared with the Pythagorean identity from our last unit. When I can, I'm going to use the cosine squared minus sine squared, especially for these types of problems. Oh, there's an X. Nope, wrong button. Because if I use these equations, this form of the equation, I'm going to get a common denominator and not have to find it myself. So from our picture, cosine is 3/5 squared, because it's squared. Sine is negative 4/5. When you square a fraction, you square the numerator, square the denominator, square the numerator, square the denominator. We get negative 7/25. For tangent 2x, since that's not on our formula sheet, and I already did the work for sine and cosine double angles, I'm going to use this identity to simplify this problem. So we get negative 24/25 all divided by negative 7/25. When you divide fractions, that's the same thing as multiplying by the reciprocal of the denominator. 25 divided by 25 is 1. Negative divided by negative is positive. And our answer is 24/7. We're going to skip this top part of page 14. If you look down, oh, okay, at the bottom, we're going to condense the left side and then use that simplified formula to find the exact value. So matching this, I notice it is in this format. So I can condense that to sine 2 times theta. So 112.5 doubled. If you don't want to multiply, you can add. (225°). So the exact value, that puts me in quadrant 3 with a 45-degree reference angle. So the sine of this picture is -1/√2. Now for number 2, that is the cosine double angle. So that's going to be cosine 2 times this theta of 15. That's asking us for cosine of 30. Quadrant 1. So cosine of this picture is √3/2. And then the last one here, I notice that fits this identity. So I'm going to condense that all the way back to the original double. Oh, that's kind of hard to read. Hang on. So 2 times pi/8. The 2 can reduce. So this is asking us for the cosine of pi/4. Quadrant 1. That's 1 divided by √2. Okay, so your practice then is to do page 11 and then 15, numbers 1 to 3.